Okay, so I'm sorry, we left off with number 11. We have the and here, so we're going to be multiplying. So I have a probability that I'm going to get D. Again, there's only one section that has D out of 8 on that spinner, and then multiply. And again, only one section with a G on it out of 8. So multiply straight across, I get 1 out of 64. Then if I go over to experimental. So experimental probability is different. This is based off of somebody actually sitting and spinning that spinner. So in this case, this section of information is our experimental probability information. Someone actually sat down and did this 50 times. They spun a spinner, and these are the results they get. For example, they spun A 10 times. So when they were spinning, every time they spun, they counted, or they wrote down what letter they got, and they got A 10 times. Okay, so if I look at this for the experimental, again, this is someone actually sitting and trying it out. So the probability that they were going to get H, well, they got 4 H's out of their 50 tries. So it's a little different again than the theoretical. They actually spun 4 out of 50. Then for the probability of A or G, again, this is the or, so it's adding. Probability of A is that they got 10 A's out of the 50 spins. And then for G, they had 5 out of the 50 spins for a total of 15 out of the 50, which reduces to 3/10. And then the last one, probability of D and G. This one, since it says and, is going to be multiply. And the probability of D, they got 2 D's out of their 50. And for G, they had 5 G's out of their 50. And when we multiply that, we would get 10 out of 2,500 reduce, and it's 1 out of 250. All right, onwards. Maybe I'm going to do that annoying sound again. Sorry. Okay, so let's go forward. Okay, in a bag full of marbles, there are 3 red, 7 green, 5 yellow, and 4 blue. What are the odds in favor of pulling a green or yellow? Okay, so odds in favor means we want a green or yellow. We have, 7 green and 5 yellow. And then, so odds would be the options for us to get it. And then now for the denominator, it's going to be the options for not getting it. So if we're not getting green or yellow, then we would have red, which was 3, or blue. So if I total those up, I really have 12 to 7, or you could write it 12 to 7. Either way. Either way is okay there. Okay, the next one, what are the odds against pulling a blue? So this means we don't want blue. So I would add up all the others. 3 red, 7 yellow, 7 green, 5 yellow, and then that would go next to over the chances that I could get it. So the top is the chance I'm not going to get it. So these are all the not blue colors. And then the one at the bottom, this is going to be all of the blues. So in this case, it would be 4. And when I add all those up, I get 15 over 4. So 15 that are not blue versus 4 that are blue. And again, you could write it as 15 to 4. All right, then we switch from odds to probability. So probability is a little bit different. Odds is how it's going to happen versus how it's not going to happen, or vice versa. Probability is ways it can happen, what you want to happen versus all the ways it could happen. So probability of 2 reds with replacement, meaning we draw one, we put it back, we draw another one. So this would be the probability of red and red. So that would be the probability of red times the probability of red, since it's an and problem, red and red. Now, when I do this, the probability of red the first time, I have 3 out of, if I total those up, I believe we get 19 total marbles. Okay, so 3 out of 19. Then I put the marble back, and whoopsie, that's not what we want. There we go. And I get, again, 3 out of 19 because I put the marble back, so there's still 3 red marbles and there's still 19 marbles total. Multiply that out, I get 9 out of, I think that's 361, and we're done with that one. Then the next one is basically the same, only this time we're not going to replace the marbles, so I'm still doing probability of red and red. So probability of red times probability of red. That's all the same, but what's different is going to be the numbers we use. So when I first draw the probability, why is it doing that? I don't know. Okay, I would say the first red I draw, there's 3 in the bag out of the total of 19. But this time, once I draw the red, I don't put it back. So now my next probability, there's no longer 3 reds because I took one out. So now there's only 2 to choose from. And now there's only 18 marbles because, again, I took one out. Then you could multiply that across, or you could reduce right here. I would probably reduce. 2 goes into 2 once and into 18 9 times. Then multiply across, and we get 3 out of 171. All right. Then you own 3 pairs of shoes, 10 shirts, and 4 pairs of pants. How many outfits can you make that contain 1 pair of shoes, 1 pair of pants, and 1 shirt? This one was all about our counting principle, which says when you're trying to combine all the different ways of things, you just multiply 3 times 10 times 4, and we get 120. Next, we have out of 100 students, 43 like chocolate ice cream, 68 like vanilla ice cream, and 35 actually like both. What is the probability that a student likes chocolate or vanilla? That question, what is the probability? That's what we're going to start with. What's the probability that a student likes chocolate or vanilla? That formula would be, and again, it's an or, so we're going to say probability of chocolate plus, because or means add, probability of vanilla. But this one has the catch that some students could like both. So we have to subtract out the students who said yes to both. So I would say probability of chocolate and vanilla. So here goes. The probability for chocolate, well, there were 43 students out of 100 that said they liked chocolate. There were 68 out of 100 that liked vanilla. And there were 35 out of the 100 that liked both. If I do that math quickly here, we would have, we would get, adding those first 2 fractions, I get 111 out of 100. And then we still have to subtract the 35. And when I subtract, I get 76 out of 100. Whoopsie, going fast. All right, number 19. 6 of your friends are in an art class of 32 students. 4 students will be chosen to leave early. What are the chances that 4 of your friends will be chosen? So this one is really about keeping it straight, what we're looking for. We want to know, we want a friend to be chosen. That's what we want to have happen out of just anyone being chosen. Okay, so if we look at this, how many friends do we have? Oh, we have 6. So this is 6 friends, and I'm trying to choose 4 of them. So I would use a combination here because the order that the friends get chosen in doesn't matter. Is whatever group of 4 gets chosen, they all get to leave. So it doesn't matter if one's chosen first or last, they're all leaving early. So I would say combination because I'm looking for the group of 4 students. So out of the 6, I'm choosing groups of 4, and then that's my friends. Then for everyone out of the 32 students, I would have all the possible groups of 4 that could be chosen. So when I do that math, I get the 6 choose 4 is 15. Over 32 choose 4, I got 35,960. And then when I divided that out or reduced it, 3 out of 7,192, 7,192. Okay, this one is not about solving. This one is about deciding, is it a combination or permutation? So it says there are 25 teams in a sports league and the top 10 teams make the playoffs. How many different groups of 10 teams could end up in the playoffs? Since this says groups and it doesn't say someone's winning first place or second place, there's no indication that there's an order involved. It's just which different teams could be combined that go into the playoffs. So which How can we group them together? This would be a combination. So if the order matters, then it's a permutation.